Good morning, one and all. In today's lecture video, we are going to see about the fourth unit of artificial intelligence. So, let me start with the introduction. So, the topic given is uncertain knowledge and reasoning. So, first of all, we need to know what is uncertainty. So far, we have completed in the third unit, we saw about the first order logic and predicate logics, where the condition should be the statement. If it is certain statement, then we can proceed with the predicates. So, say for example, if I say as A implies B, which means that if A is true, then B is also true. But consider where we can have the situation like A is true and not, then we cannot express this statement. So, this is called as uncertainty. So, we need uncertain reasoning or somewhat with the help of the probabilistic reasoning, we can represent the uncertain knowledge. So, in the next slide, we are going to see about what are all the causes of uncertainty. So here are the few examples or few occurrence of the causes. The first one is called as information occurred from unreliable resource, which are all the resources which are not trustworthy. That is uncertainty, and where we can get experimental errors and where we have equipment fault. These are the situation where we can handle uncertain things, and there may be a variation in temperature and there may be climate change. So for these kind of uncertainty, the only representation we have is called as probabilistic reasoning. What is actually probabilistic reasoning is where we apply the concept of probability. You know what is the value of probability? Either it can be 0 or 1. 0 means it's uncertainty and 1 means it's certainty. So we have lots of scenarios in real world where the certainty is something is not confirmed. Say for example, you may hear like it will rain today, but it won't happen. And we can say a best example as someone will behave like something in some situation which is not predictable, and there can be a match between two teams, but it may not happen. So these things are called as uncertainty, which can be handled through probabilistic reasoning. And why we need probabilistic reasoning in AI? So there may be some unpredictable outcomes may be there, and the specification or the data may be too large, or it is it is too large to handle. If suppose any unknown error occurs during an experiment, at that time we may require probabilistic reasoning. And to solve this, we have two things. One is two rules actually, I can say, like one is Bayes rule and Bayesian statistics. So before going to see this Bayes rule and Bayesian statistics, let's see some common terms in probability. So as I told before, what is meant by probability is, if any uncertain event happen, with the help of this probability we can judge things, whether we can say it can occur or not. So as told before, it's just a numerical measure where 0 remains 0 indicates uncertainty, and the probability of A, which we can represent it as P of A, it is 1 means it is totally, for that particular event A, the certainty happens. So it lies between what? 0 and 1. And the next thing is, you have a formula here. We can find the probability of an uncertain event by using the below formula. That is, this is the basic things. Probability of occurrence is equal to number of desired outcomes divided by total number of outcomes. So P of negation of A is equal to probability. P of negation of A plus P of A should be 1. So the event here happens is each possible outcome of a variable is called an event. The next comes is the conditional probability. When this conditional probability occurs is when an event has already happened, so that time you can use the conditional probability. Say for example, we want to calculate the event A, but event B has already occurred. So the probability of A under the condition of B, it can be written with the help of the formula P of A bar B, which is equal to P of A intersection B divided by P of B. Whereas A intersection B means the joint probability of A and B, whereas P of B is the marginal probability of B. So let's stop this lecture up to this. We will continue with the examples in the next video lecture. Thank you.